change of mass which is happening in tank 1 is equal to rho into Q minus rho into Q1. Again, taking rho constant, if I write Q minus Q1 into rho. Again, if rho and rho are getting cancelled, A1 H1 is equal to Q minus Q1. That is there in the tank for the tank number 1. Similarly, for tank number 2 is rho into A2 into H2 is equal to rho common Q1 minus Q0. So this is for tank 2. The same whatever equation we had written here, this equation whatever we had written here, the same equation we are writing here, because what is changing here in case of tank 1, the mass flow is equal to rho into H1 into A1. The mass flow which is present in tank 2 is equal to rho into H2 into A2. That is what is here. Why it is dot here? It is change of height. So otherwise it will be we can write it as d by dt of h, d of d or dh1 by dt. Similarly here dh2 by dt, or you can directly write dot here. So that is also okay. So I think these two equations are self-explanatory, or it is already explained. So what you can do is you can just see here q is equal to h1 minus h2r. But here now just observe here. Once having understood this, we'll just go to the next slide. In next slide, but the flow q1 is proportional to the difference between heads h1 minus h2. Now, as we had seen here, because we know that h is equal to r into q. Similarly, what is happening is q1 is equal to h1 minus h2 by r1. Understood here? Is there any doubt here? Is this clear? Similarly, in case of for outlet q is equal to h2 divided by r2. So what we are doing is q1 and q0, whatever are there, we are going to substitute that in this 1.1.11 and 1.1.12. So q1 and q0 are being substituted there. So what we are going to get is we get a1 h1 is equal to q minus h1 minus h2 divided by r1. Similarly, this q1 is substituted here, h1 minus h2 divided by r1, and what is q0? H2 divided by r2. So this is the two equations for mathematical model of two coupled tank systems. Okay. So I'll just repeat it once again. So what is the condition here? We have two tanks which are interconnected by a wall. There is one inlet pipe from where discharge q is coming, and we have a tank which is connected to this, whose area is A1, and the height of the liquid which is present in that is H1. So the mass is equal to rho into A1 into H1. It is connected, tank 1 is connected to tank 2 through a wall R1, whose resistance is R1, and the discharge from tank 1 is Q1. Then the water height in case of tank 2 is H2, area of tank 2 is A2. So the mass which is present in tank 2 is equal to rho into A2 into H2. And tank 2 is connected to the outlet through a wall 2, whose resistance is R2, and Q0 is the discharge which is happening through the wall 2. Now, so here mass change which is happening in case of tank 1 is equal to rho constant q minus q1. Similarly, the mass change which is happening in tank 2 is equal to rho constant q1 minus q0, and we know that q1 is equal to h1 minus h2 divided by r1. Similarly, q0 is equal to h2 divided by r2. Substitute q1 and q0 in equations 1 and 2, we get a1 h1 is equal to q minus h1 minus h2 divided by r1. A into h2 is equal to h1 minus h2 divided by r1 minus h2 by r2. So this is what we are going to get. So I'll give around 2 to 3 minutes for you to just observe here. If there are any doubts, please let me know, or else we'll continue. I'll go ahead with the further part. Any doubts are there? Because remember, this is very important. Either of two, one question is usually asked in exam. Do we have any other doubts? Any doubts? Okay.
No, sir.
Mark these two questions. Yeah, you can note it down somewhere or just remember it. This is the most important question. Either of these two, one question is usually asked in exam. So then we have the mathematical model of a thermal system. So in if you just go with the syllabus, 1 minute, I'll just show you the syllabus also for your understanding. In case of syllabus also, we have that part, mathematical model of systems. Just a second. If you just here, mathematical model of motors, AC motor and DC motor, mathematical of thermal systems, mathematical model of hydraulic systems. Pneumatic system is there, but you never had even asked. So we usually try to skip it. We don't go with the pneumatic method. We usually go for what? AC and DC motors. We go with the hydraulic system that we have just done now. And we are now, I'm going to go with the thermal system. So what is the thermal system? That we'll just understand now. What is the thermal system? We'll just understand. Now, here basically it is what we have one tank. We have one tank, and there, because of stirring, the heat is getting generated. Because of stirring, the heat is getting generated in the thing. You can just see here, there is one tank, and we have a stirrer, and theta 1 is the temperature of the surrounding temperature, and theta 2 is the temperature of the water. So this is what is happening. So let us understand this. What is the thing? In a thermal system, heat is transferred from one medium to another, that is known to us. The rate of heat transfer is denoted by Q. So what is the Q? Q is nothing but rate at which the heat is getting transferred, and it is proportional to the temperature difference across this. So it is similar like what concepts you had done in your heat transfer. So in case of heat transfer, what is heat? Temperature divided by resistance, thermal resistance. I think this is there in your conduction experiment. I suppose you remember, just last semester only I had done it. So the Q is nothing but temperature difference into resistance. Now, what is this resistance? Resistance is nothing but delta X. What is delta X? The temperature or the thickness of the system divided by K. What is this? Thermal conductivity of the material, and A is nothing but the area. So here, if you just remember, the rate of heat transfer is equal to temperature difference across the medium divided by the thermal resistance. Thermal resistance is given by delta X divided by K into A. Now, similarly, what this, in case of, if you remember, composite experiment you have done, composite wall experiment you have done, in this, the same concept was there. You usually used to take the temperature across bakelite, wood, as well as the steel plate. So, and you knew what was the thickness of the plate. Usually it was 200 mm. Then thermal conductivity of the material was known, and you knew the diameter. So knowing the thermal conductivity of the material, or you used to find the thermal conductivity, and you used to get this. So the same concept we are applying here. So heat transfer is equal to temperature difference divided by this. So what is thermal resistance? Delta Q divided by K into A. So this you no. But we know this is a common thing is the rate of change of temperature and the rate of change of heat transfer are related by this. How? It is mCp delta T. I think you know what is the temperature, that is the heat, is equal to mCp delta T. If I take unit mass, it will become 1 into C into delta T. That is what is related. So this and this are interrelated. So what we are doing is Q, we know there is one more thing. So it is mCp delta T that we are taking. So we are equating these two. We are equating that Q is equal to C delta T into D2. Now, so just observe here. I think this point is clear. Any doubts with respect to this? Do you have any doubts with respect to equation 1.1.21? Is it clear? Now, the thermal capacitance is a product of mass and specific heat. That is known because mass into that is what we have already done, because mCp delta T is similar, that the same thing is taken here. Whatever CT is nothing but mass into specific heat. It is what is here, mass into specific heat or thermal capacitance. That is equivalent. Now, if we just consider the tank in which let us consider that water is there and it is getting stirred. Water is getting stirred. Now, in order to attain the equilibrium, the heat is going to get transferred from one point to another. Let us consider that here, whatever the water is there or the liquid is there, which is at degree T2, is slightly hotter, or sorry, it is this, and heat is getting transferred from one medium to another. So, and that atmospheric temperature is at higher temperature. So we are going to get this. So theta 1 minus theta 2, or depending upon the temperature, whatever it is, whichever is hot or whichever is cold, the heat is going to get transferred. In our condition, let us consider theta 1 is greater, theta 2 is smaller. So theta 1 minus theta 2 is this. So because liquid temperature theta 2 and surrounding temperature this, and this is given by theta 1 minus theta 2, we have this. So Ct into d T2 by d2, that is whatever is here, the same thing is taken here, and we know that by Q, theta 1 minus theta 2 divided by RT. So we could equating these two equations, that is 1.1.23 and 1.1.21. We are equating this, and by this we get that, and RT is multiplied on both the sides. When you multiply RT and rearranging the terms, so we have, and rearranging such that theta 2 is only on the one side and theta 1 is on the other side. So RT into Ct divided into d theta 2 divided by dt plus theta 2 is equal to theta 1. So this is the mathematical model of the thermal system. So this is the mathematical model of the thermal system. Do you have any doubts with respect to this thermal system? Any doubts are there? Do you have any doubts? Yes, if any doubts are there, please let me know. Yes.
No, sir.
Okay.
So, but.
Tell me.
So, but then, so can you open it?
Just a second. Tell me. Tell me. Yes.
Yes, sir. So, are we going to substitute the value of RT and CT?
No. It is only this much what you are going to keep.
So, and what about the equation? Those are below, sir.
This part.
No, sir. Next page, sir. So this one,
this no? On slide number 7.
Yes, sir.
Slide number 7 you'll have to explain, because this usually comes for 10 marks. Got it?
Okay, sir.
You have to initially explain these two. These are very simple. Then once you have explained this basic concept, then you have to consider this tank and only substitute here. This is for 10 marks. Sometimes if your luck is good, the same question can be even asked for 12 to 15 marks. I think there is no much easier than this. Very simple things are there. So remember, you can mark this question on mathematical model of this. I'll just come back here. In this 4, one question you can fix. One among this will be there in your final exam. Among this 4, one question is guaranteed. Is of either 12 marks or 10 marks. 10 or 12 marks is the compulsory question which comes. Especially this on motor, either of 2 will be there. Sometimes if the paper is slightly lengthier or slightly difficult, they will ask on motors, or else there will be question on liquid level or thermal level system. It will be problem on liquid level or thermal level system. This is what is there. So,
okay.
Do you want me to repeat these two once again, or it is okay?
Sure, it's okay, sir.
Okay. So regarding this, we are going to discuss regarding motors, but I understand that motor part you have dealt it very long back, and you had and some students may have even skipped that motor. So what I'm doing is, because even for us electrical part is slightly difficult for, especially for me slightly. What I have done is to rebrush your basics, I'll post this PPT on motors. I'll just post a PPT on motors. I'll just show, you can just go through at your leisure time. So what I'll be doing is, I'll put one PPT. You just go through that. By next time, the next class will deal with this part. That is this. That is armature controlled DC motor. One simple derivation is there, and field and armature controlled and field controlled DC motor. These are the two important on which we are going to discuss. So today, whatever part I wanted to discuss was only these two. That is thermal level system and liquid level system that we have discussed. Regarding motors, I'll be discussing in next class only, because as I told in the before starting, we are slightly ahead, because other class they are slightly one division is in still in block diagram, or they have just started with the signal flow graph, and in order to match them, slightly I'm going slow. So this whatever we have discussed regarding today was only a liquid level system and thermal level system that we have done. Regarding this AC motors, I'll give you the PPT. You just go through that PPT. Next class, having understood the concept, we'll just discuss what are these important parameters and deal with this. Is it done? Is it clear? Hope diploma students, motor part was there in your diploma. Somewhere you have studied it.
So stepper motor and servo motors were there.
Stepper motor and servo motor. Okay. So and for I think even electrical for this non-diploma students in basic electrical, whether you have gone through motors part. Yes, can somebody let me know? Neeraj, was this or cable? Anybody? You have done this, Nikhil. I think that motor part was there in your basic electrical. Which all things was cleared in your this in your basic electrical part? Because some important concepts are there. If you understand, then the derivation you can understand. I understand that. Okay, AC and DC motor only. No? Okay, so what I have done is I have, because since we are only dealing with DC motor here, I'll just post that DC motor basics for you. You just go through that. Then regarding whatever is their part for our derivation, that we'll discuss. And if there is any need arise there, I'll just come up with the concept regarding the DC motor. Okay, so with this, I'll conclude today's class. And the next class where we are meeting is during that time, we'll discuss the derivation regarding that AC and DC motor. Okay. Do you have any doubts with respect to the thermal level system and liquid level system? Any doubts are there? Do you have any doubts with respect to liquid thermal level systems or liquid level systems? Okay. Okay. So with this, we'll conclude today's class. Thank you.
So do we have a class after this or?
No. That is only because in order to match our portion with the other division, I have taken not to take another class, because we are already very far ahead with respect to other divisions, because they have still started signal flow graph. So in order to accommodate one class, and for that reason, only one class. So next class which is at 1 to 2 is not there today. Only today. It is only today.
Thank you, sir.
Okay.